Hello, everybody. It's Emily. This is Lab 1, the Charge Tape Lab, Physics 2. Let's get started. So today we're going to uncover the realm of particles. We're going to use conservation of charge. We're going to add the electric force to our other bank of forces. We're going to dust off our computational skills by modeling the electric charge online and in real life. And we're going to learn about the triboelectric series, which is basically a series that describes the properties of materials and how easy they lose electrons. So the fact that we have one piece of tape that's negative and one piece of tape that's positive, which one is positive, which one is negative, decided by the triboelectric series. And the charges could switch based on different materials. So yeah, we've got two pieces of tape. They're both charged. We're going to model it online. We're going to model it in person. And then we're going to figure out at the end that basically the two wimpy little pieces of Scotch tape and that electric interaction beats the gravitational field of the Earth. So that's cool. What are we going to need? We're going to need Newton's second law, or the momentum principle. We're going to need free body diagrams. We're going to have to figure out the force of gravity and the force of the electric field of the electric force on one of the tapes, the top tape specifically. Yeah, so our system is the two pieces of charged tape and the Earth, and our surroundings is everything else. Some things we got to take into account is my hands touching the tape, the plastic containers touching the tape, the air touching the tape, maybe the charged particles of the Earth touching the tape, like everything. Like it's not perfect, but it rounds to perfect. So what exactly the steps are is we're going to have a 20 centimeter piece of tape. We're going to put it on a piece of table. We're going to make an identical tape, put that one on top of the other one, rip the electrons off of the first one and onto the top tape. And we're going to make that twice. We're going to have those two interact. I've drawn a little diagram for you here. So once we've ripped everything off, basically the top one is literally ripping the electrons off of the bottom one. And the triboelectric series figures out the top one is the one that gets the negative charge. And also, we're only looking at the bottom part of the top tape, the top part of the top tape and the bottom part of the bottom tape, because again, tape is an insulator. So it's not like the charge isn't distributing throughout the whole tape. So let's look at what we did with math. We set up the momentum equation. We have it as an equilibrium problem because the levitating piece of tape is counteracting both gravity and the environment, the electrical field. They balance each other out. And so we set them equal to each other. We move all our variables aside and just find the charge of the tape, which was the goal, is find the charge. What's the charge after we've ripped all the electrons off of the bottom piece of tape? Now that we know the charge, though, it's about 3.5 times 10 to the negative 9 coulombs, so 3.5 like billionth of a coulomb, I guess. And so to find how many atoms are getting ionized, you need to know how many atoms are in the tape. And that is like the area of the tape divided by the area of an atom. It's cross-sectional, but like the atom is basically flat, and so is the tape. And so I find the total number of atoms with that. And then I have the charge that I found earlier, divide that by the number of atoms, and I get the number of charged atoms. And it's about 1 million atoms gave up a charge at the bottom tape, and 1 million atoms took a charge at the top tape, in the top tape. So that's cool. That's a lot in terms of like atom world. And so I modeled basically those two equations online. We've got the force of gravity, the tape charge, the atom ratio, and we get this little like ball and the arrows. We've got the electric field balancing out the gravitational fields. Very cool. The similarities and differences, the tape isn't a point particle. That's the biggest one. Also, in real life, the two pieces of tape are like super wavy, and the glow script really explains that it's like not a permanent, like the real life model is not permanent, and glow scripts are just like a single snapshot. I think it's important to notice that difference. And yeah, also I'm touching the tape a bunch. And so the two charges aren't exactly the same as we have modeled in my math and in glow script. Because everything touching themselves. Anyways, what if an electron and proton switch charges? This one kind of stumped me here because, like, what makes a particle have a charge? And I think it's a quark configuration, but even then, people aren't like super sure about that. So, if an electron and a proton switch charges, I think their masses would also need to be different because their quark configuration would be different. And an electron isn't even configured of quarks, but a proton is. So, the electron have to have quarks now, and the protons wouldn't, and that would change its particle type, which would change the rules of its interaction. And I think the universe would like basically fall apart. So what would happen? I don't think anything would happen because we would never exist. Why is it important not to touch the tape during the experiment? Well, because my hand, the neutral object, is interacting atomically with the charged tape. I'm stealing back some of the electrons that have charged the tape, and thus making the tape not exactly as equivalent to the other piece of tape, which is like not being touched by the electrons or by my hands. And so it just makes the math messier. But anyways, I thank you.